I'm going to cover some basic Python math in this notebook. We'll cover the numeric types, checking the type of variable, how to change the type of a variable, both permanently and temporarily. We're going to show some comparisons, cover the order of operations back to elementary school. We're going to use some of the built-in math functions, very few built-in math functions in this notebook, and we'll show some practical examples. So the first thing I'll talk about is the numeric types in Python. Simply, an integer is for whole numbers and a float is for decimal numbers. So fractional numbers will definitely be covered, but as a computer we're going to use decimals for any fraction of a number. In the example here, our variable a is 10 and variable b is 3.5. If we print them, we'll see that this does not have a fraction, and this does have a fraction, and this one has a fraction as well. So this is going to be an integer. And we'll test that here. We'll print the type of variable a, and we'll print the type of variable b. We're going to do this between, and then we're going to do it again at the end. And we're going to see that variable a is an integer, and variable b is a float. But as we assigned a new value, it changed the value to float. And that occurs in Python as expected. It's very different than some other programming languages, so it's important to know that this is a dynamically typed language, and the type will change whenever you assign it to something that is different. So we've actually changed the variable from an integer to a float simply by assigning a decimal number to it. This will also work the other way. If I assign b a whole number of 5, and I print type b, we'll see that now this is back to an integer. If you want to check the type, as the example up here, you can print with the function type the variable in parentheses, and it will show you the type of variable. If you want to change the type of the variable, you can use various casting commands. This is just a couple of the ones that are available to change something from an integer to a float. We see here that we're printing 3.9, which we know is a float, and we're casting it to an integer, and our output is 3. It simply removes the fractional part of the number. If we have a 5 and we cast it to a float, it now becomes 5.0. If we cast an integer of the string 12, you can see here that we're in quotes, we're a string, we're casting it to an integer. It is now an integer of 12, no longer has that string type. We did the same thing here with 12.5. That's a string, and we've casted it to a float. And now it can become a number. You can create a float just by dividing two integers. So if we divide 5 by 2 and we check the type of that, we'll see that that is a float. This occurs even if they're whole numbers. Even two whole numbers divided together where the answer would be a whole number, it will still be a float. Now, if we know that that is going to be a whole number, we can cast that into an integer. And then we'll get a whole number. Python will sometimes give ridiculous answers with floating point numbers. There is probably entire books on how Python and other programming languages might do this. But it is an important thing to understand that this will occur. So if you do want to limit the number of decimal places so your code does not do this, it's important to use the round command. You'll put in the variable or the math problem here, and then after the comma, the second operator will be the number of decimals you want to return. So in this case, it's 2. If we do an example, we'll return 4. We can return 8. It would drop anything that's 0. If we were to use 15, no change. Python has various operators. The first 4 seem pretty normal, but then we get into 2 different types of division: floor division and modulus, which is the remainder of the math problem. You'll use 2 asterisks to use an exponent. Now, often that may be written in other terms like this, but Python is going to use 2 asterisks rather. Now, one of the interesting things about floor division and modulus is knowing what kind of output you want to provide in your program and how you want to calculate these numbers. If you use a division symbol, it will simply return your float in decimals. But if you want to return the whole number and what is remaining, you can use 2 slashes, which will return just the whole number from the division problem. And you can use the % symbol to return just the remaining value. The best example that I've seen is calculating time, minutes and hours. If you were going to talk to an Android or a computer, you may wish to use a decimal number. 1.25 hours is very precise, but it doesn't sound good if you're giving time to a person. In that case, you may want to do 1 hour and 15 minutes. In that case, you would do the floor division to show how many whole hours are in this math problem of 75 minutes and the minutes that are remaining after you've calculated the hours. And in that case, you would use the math problem like this. Now, if you had more minutes, if you had 194 minutes, and we ran this, we could see that this is a very complex yet precise answer. But if you were going to give this to a person, you may want to say 3 hours and 14 minutes. There are various ways to calculate values in Python, as well as any programming language, and here are a few examples. We can check if a number is equal. We can check if a number is not equal. We can do greater than and less than. And we can also do greater than or equal to, or less than and equal to. The examples here all evaluate as true. The next thing we want to consider is order of operations, abbreviated as PEMDAS, for parentheses, exponents, multiplication and division, addition and subtraction. This is probably very close to what you learned in school, but it is given a specific name here. And this is a quick example to show you how it matters if you're using, in this case, parentheses to change the order of operations, primarily to do this math problem before multiplying by 4. Python has a plethora of built-in math functions, and there's even an entire math library we'll cover in another video. But a quick example is getting an absolute value, how far a number is from 0, rounding a number, such as pi here, to 2 decimal places, and finding the minimum and the maximum in a set of numbers. This was covered in another video, but we'll look at it again. There's a shortcut in Python to increment and decrement a variable, a value, an integer. So it's very good in a counter, whether you want to count up or count down. This is an example of counting up by 1, counting down by 1. And if you want to change how much you're incrementing or decrementing, you can use a different integer. In this case, we're going to count up by 5. In this case, we're going to count down by 3. Another quick trick to do with a modulus is finding out if a number is even or odd. When we divide a number by 2, if it's an even number, we're always going to get the answer of 0. And if we divide an odd number by 2, we're always going to get a remainder of 1. So you could use this in an evaluation to find out if a number is even or odd, if you have a single or a pair calculated in your expression. So in this lab, we covered our numeric types, how to check a type, how to change an integer in a float, some basic arithmetic operators, how to do comparisons, going back over our order of operations, and using just a few built-in math functions. And we covered again the increment and decrement shortcuts, and this quick check on how we can find out if a number is even or odd with one expression. Thank you.